Which statement explains why the compound propane, whose molecular formula is C3H8, 3 carbon atoms bonded to 8 hydrogen atoms, as well as carbon dioxide gas, okay, which has 1 carbon atom bonded to 2 oxygen atoms, diffuse at the same rate at RTP. RTP stands for room temperature and pressure. Room temperature is about 25 degrees Celsius at the pressure of 1 atmosphere. So that's what we mean by RTP. So which statement explains why the compounds, these two compounds, diffuse at the same rate? For two compounds or two gaseous molecules to diffuse at the same rate, okay, they should be having the same density. In other words, they should be having the same relative molecular mass. So for the same rate of diffusion, both propane as well as carbon dioxide should have the same relative molecular mass, or the MR values for short. So if you look at the MR value for C3H8, so there are 3 carbon atoms. So 3 times 12, because each carbon has a relative atomic mass of 12, so thrice of 12, plus there is 8 hydrogen atoms bonded to it. So 8 times 1, because relative atomic mass of hydrogen is 1. So 3 times 12 is of course 36, plus another 8 times 1, which is 8. 36 plus the 8 is going to work out to 44. Now if we look at the carbon dioxide, okay, there is 1 carbon and bonded to 2 oxygen atoms. So the carbon's relative atomic mass is 12, and there are 2 oxygen. So each oxygen is 16, so we need to add twice of 16. So 12, you add it to twice of 16. 16 times 2 is 32. 32 plus another 12 is going to of course work out to 44. And as you can see, both, okay, propane gas as well as carbon dioxide has the same MR values, which means they are equally dense. And of course, if they are equally dense, they're going to diffuse at the same rate. So the option that says, okay, explains why the compounds diffuse at the same rate, it is because they have the same relative molecular mass, or the MR value.